So I'm glad that you tuned in for this one because this is a particularly important problem. It's a longer problem, a little bit more challenging, but we'll get through it. It's going to, I think, take the whole board, but we'll work our way through it. So it's inspired by a problem from 6.6, inspired by number 18, by the way. But I made a couple adjustments to it to make it a little less onerous, I guess, a little not so long, we'll put it that way. Nonetheless, the instructions for this exercise say we should use conditional or indirect proof to derive this conclusion from these premises, right? So, looking at this conclusion here, actually we'll notice that unlike the indirect proofs we've been looking at up to this point, we have a main operator horseshoe here in our conclusion. And so I'm hoping that you all will agree with me here that it will be a good idea, in fact, to approach this as a conditional proof. And so we're going to assume K dot L in order to get tilde n. We're going to assume K dot L in order to get tilde n. That's how we would set up a conditional proof here, right? You assume the antecedent in order to get the consequent. And so this would be a good review of conditional proof then as well. So we have our assumption here. As you know, I want to use my assumption right away if I can with these other premises that I'm dealing with. And so I hope we can all notice right away that the main operator of these two premises would be the horseshoe in each case, and the antecedent of each is the K here and the L there, right? In other words, if we can break down this K dot L, we'll be able to then use the K with number 1, we'll be able to use the L with number 2 as a modus ponens. So, simp number 3, and I'm going to go ahead and just break this all down so I have my pieces handy. We're going to do comm on number 3. So we can simp number 5, right? So we have K by itself and L by itself. And of course, the motivation for that is because these look very useful with 1 and 2 there, specifically with modus ponens in mind. And so we can hopefully straightforwardly do modus ponens with 4 and 1. Giving us n wedge m horseshoe q. That's modus ponens 1 and 4. And then we can do a modus ponens with 2 and 6. We've got the L there. So modus ponens 2 and 6 gets us all of that. So got these two pieces here we've broken down or boiled down the two premises in our assumption down to this. We got to this point. And it's at this point then, since we've used all of our premises and our assumption, I want to remind myself, well, what am I trying to get? Good thing I left myself a note here, especially for a longer problem like this. I'm trying to get tilde n. Tilde n. Well, there it is, tilde n. So to get the tilde n, I just need to get q wedge r. But how do I get q wedge r? Well, there's a q here in this other line. But we can't add on a wedge r to line 7 here, at least not just to the q part, because addition works on a whole line. You can't just add on a wedge r to a part of a line 7 here. So, yes, the tilde n is there. It's very tantalizing. It's very appealing. But how are we going to get it? The problem. And so, honestly, we could have a couple options here. We could start to use replacement rules to break down number 7 and 8. But that's a bit of a mess, or even more than a bit. It's a big mess to try and break these down using replacement rules. Or we could do this. We could think about this, right? We wrote down here, get tilde n. This here in parentheses, this is basically a conclusion for this indented sequence that we're in here, right? It's a new conclusion for us, a new goal for us to get. Well, just as we've been doing an indirect proof, right? If this were, tilde n were, just to say, if this were some, I guess I've written that off the screen here. Sorry about that. if tilde n were some conclusion for some other problem, right, we know what we would do with that. We would do indirect proof to get tilde n if we have that capability. And so that's how we want to think about tilde n here. We are trying to get tilde n, and a good way to get tilde n would be to do indirect proof to get that. And if we're going to do indirect proof to get tilde n, what we would do is indent, right? We would indent and assume the opposite of tilde n, which, as we know, could be double tilde n, or more conveniently, could be simply n. We can assume the opposite of this, which is in this case just n. And at this point, then, we're trying to get a contradiction. We're trying to get a contradiction. We assume n to get a contradiction, right? Just think about how this is going to work. We assume n, we're going to do some work, going to get a contradiction. What is that going to enable us to write? It's going to enable us to write tilde n, which is what we wanted to get here. Once we get tilde n, it's going to enable us to write our conclusion, right? Now, I understand if some people are sort of intimidated by this step, right? I've had students in the past compare this particular problem where we're indenting and then indenting again to the fairly convoluted film Inception, if you're familiar with that film. It's sort of like the dream within the dream, if you understand the plot of Inception. I don't know that anybody really understands the plot of the film Inception, but nonetheless, it's complicated. That's the lesson here, whether or not you've seen that film. This is complicated, I agree. However, I do encourage you to do this, because if you don't do tilde n here, if you try and just approach this, we might say, head on, you're in sort of replacement rule hell here, trying to maneuver these pieces together to get that tilde n to come out of there. Think of making this new assumption here as sort of giving yourself a gift, right? You're giving yourself n, and just look at how handy that is. Because once you have n, just got to clean this up here real quick. Once you have n, look how we can use that with these other premises. N wedge m. We've seen that before. So I'm going to start over here. This is indented twice now, line 10 is. And so we have n. We can get n wedge m by addition to line 9. Very easily, very easily. We have n, we just add on wedge m. What does that enable us to do? Well, that enables us to do modus ponens with 7 to get q. Modus ponens 7 and 10 gives us the q out of number 7 here. Why do we want q? Well, we don't know that we do, but the one line we haven't used here so far is line 8. 8 has q wedge r. So to use line 8, we can simply add on, sorry, that's 11. Line 8 is what inspires us to add an r, but we're actually adding to line 11 here, the wedge r. Why would we do that? Because now look at 8 and 12. P horseshoe q and P once again enables us to write, what do you know, tilde n. That's modus ponens 8 and 12. Now, we don't want to get too excited about this. Yes, we wrote tilde n here. But remember, we're not trying to get tilde n anymore. We're trying to get a contradiction, as I've written right here. We're trying to get a contradiction. Now that I've used both of these lines, though, can I get a contradiction? Do I have something and then the same thing with a tilde in front of it? Well, you bet. I've got n right here. I've got tilde n right there. So just as we've been doing in indirect proof, we just conjoin n and tilde n. So that's lines 9 and 13. Sorry, I'm squeezing that off the edge there. If I can get it in there. Okay, conjoin lines 9 and 13 to get n dot tilde n. And guess what? Of course, that's a contradiction. Since in this double indented level, right, we were doing indirect proof, once you get a contradiction, you unindent. You only unindent one level at a time, and the procedure here is easy. You simply write down your assumption, put a tilde in front of it, and that's indirect proof. In this case, lines 9 through 14 gives us tilde n. Well, guess what? On that indented level, on the one indent level, we were trying to get tilde n as we left ourselves a note right there. Once we get tilde n, we're doing conditional proof on that level. We unindent, and once we are doing conditional proof, good review here, the procedure is always the same. We write down our assumption, k dot L. We write down a horseshoe because we're doing conditional proof, as we made a note of here. And then we write down the last thing that was indented, tilde n, and that's conditional proof lines what? Lines 3 through 15. And what do you know? That's our conclusion. There it is. And so we're finally done. So I know this is a long problem, and it can be intimidating to make this second assumption. However, trust me on this. This problem is much easier if you make this second assumption than if you don't. In fact, I'm not even sure how you get to tilde n if you don't make that second assumption. Okay? So give yourself that gift. Don't be intimidated by making a second assumption if it makes sense to do so. I think in general, making that second assumption can certainly make these problems easier than would otherwise be the case. All right.